Okay, so now that I've got the mu as 100 and then the standard deviation as square root of 50, I'm just going to form the new distribution because we converted from a binomial to a normal distribution. So I'm just going to call it y this time because that was for binomial distribution. So normal distribution, mu is 100. Standard deviation was square root of 50 square. So that's our new distribution. If the question was asking what is the probability of getting more than what's the probability of getting more than 70 heads, because this question was about tossing a coin 200 times. So if they say what's the probability of getting more than 70 heads, what we would do is we would use this distribution to do it. Again, we know from the previous section that the lower is going to be 70, upper is going to be 10,000, because this time we're using normal distribution. So we've changed that normal binomial to a normal distribution. We're doing this. So mu as 100 and sigma as square root of 50. Now, the only complication that we would have from this conversion from binomial to normal distribution, everything is simple. You've got the formula in the formula booklet. You just do 200 times half. You find the answer. 200 times half times 1 minus half. You find the answer. These are all good. You change it, rewrite it. Then you stick to the question, lower, upper, mu, sigma. Now, because we converted from a binomial distribution to a normal distribution, there's this disalignment between the data set. Because this was a discrete data, this was a continuous data. We defined it at the beginning. It's normal means continuous, binomial means discrete. This was a specific 200 times that I'm tossing the coin. So from a discrete to a continuous, when we do it, that disalignment should be corrected. Disalignment is like because we were expecting everything to be specific, and as soon as I've changed it to a normal distribution, I'm expecting this to be like a range of answers. So that disalignment, to correcting that disalignment, is called continuous correction or continuity correction. The continuity correction is easy, but people forget to do it. Like how I've started here, this is what people will do. Don't start that. Always, once you change it, remember continuity correction. It's just a theory. Just remember, do it a couple of times, it will get into your head. Continuity correction, you just draw a number line. Question was greater than 70. So greater than 70. Now, if they say greater than 70, I know that I'm passing. So greater than 70 means 70 is not included. I'm going to start from the next number. In a binomial distribution, I'll start from the next number, 71 onwards. But because we know we change from a binomial to a normal distribution, we're going to have to think there will be numbers in between 70 to 71 also could have taken it. Therefore, we use the upper bound of this number to start with. So we're not going to do it for 70, although 70 is the question. We won't do it for 70. We would do it for 70.5 because it started above 70. So you would put 70.5. So the lower will be 70.5 and not 70. Remember, that's really important. Now, there might be questions where it would say greater than or equal to 70. If they say greater than or equal to 70, you have a number line. 70 is there. This time, I had to shade this because it's including 70. Now, I want the number 70 to be included when I do normal distribution. In this case, I'm going to have to start from 69.5. I start from the lower bound. If I start from the lower bound, 70 will be included in my answer. So I would start from lower 69.5, upper as 10,000, and then mu and sigma as what we calculated. Suppose if it was, let's say they've given less than 70. If it's less than 70, 70 is there, you start less than 70. So in this case, how I'm seeing this as, do I need 70? No, because it's less than 70. 70 is not included. So I want the next number that is less than 70, not 69. In a binomial distribution, it will be 69 because binomial is specific. It's either 70 or 69. You can't have like in between in a binomial distribution. In a normal distribution, you can have numbers in between as well. That's why it's called continuous data. So how I'm seeing this is that you have to start from the lowest number, which is lower bound. So 69.5. Suppose if this was less than or equal to 70. In this case, it's taking the 70. That means I don't want to be starting from a lower bound because I want the 70 to be included when I start the question. So in this case, I would start from 70.5. If I start from 70.5 only, 70 is included. So I'll start from 70.5. So probability of less than 70.5. If I do this, 70 would be included in that. In this question, I forgot to write it. So which is less than 69.5 because I don't need 70. I start from 69.5. So it's just that number line and then the understanding. Do I need this number to be included? If it is, start from the upper bound. If it's not included, then start from the lower bound.